Hey guys, welcome back to the channel. Welcome back to another video. Love to see everyone coming back to the channel for another video, and especially one in tech. Happy holidays. Hopefully everyone is enjoying their time off work, school, or maybe some other responsibilities that you have. But if you don't know, around this time, it is typically a good time for me to start fixing some of the problems that I see throughout the year. And there's one problem that has been bothering me for the last couple of months, but I have not been able to get to it. And it has to do with the server that I built specifically for this channel, I think over 3 years ago now, which is kind of interesting. Now, before going into the problem and then diving into how to fix that particular problem, if you're new to the channel, welcome, glad to have you here. And for my subscribers that are returning, I love you all. Thank you for being here. And one favor that I'm gonna ask from you guys is make sure you hit the like button as it helps the channel grow. Go ahead and subscribe to the channel and turn on your notifications so that way you're notified whenever I upload new videos to the channel, and share this with a family member or a friend. So when this channel was first created over 3 years ago, I think that's actually where we're at right now. Yeah, somewhere around 3 years. I actually built a server specifically dedicated for this particular channel. And I think I have some of the videos of me recording it back then. Now keep in mind guys, I know I was just starting, so the quality may not be as good, but this was video that I have from me building the server specifically for YouTube and a couple of other things. And if you've never done YouTube before, one of the things that I can tell you is, especially if you're recording in 4K like I'm doing right now, those files are big in size, right? You have to capture all that resolution. After you're done editing those files and you upload everything to YouTube, you still have the project itself that is remaining, meaning all the source files in order to build the project, and then after as well, the final product, right? The project directory starts to grow very, very big in size, and you need somewhere in order to put that. So therefore, this server that I did over 3 years ago was really geared for storage purposes and making sure that I have somewhere to put my videos or my projects for long-term use, or as we like to call it, archiving. Now, at the time when I was putting this server together and I was thinking about what hardware I would need, I said to myself, let's start off with 3 hard drives, and this is going to be spinning hard drives. And that gave me a total of 32 terabytes for storage. And you may be asking, well, 16 times 3 is not 32, so what happened to the last hard drive? And that last hard drive is specifically meant for parity. And if you don't know what parity is, all it is a hard drive specifically dedicated so that way if one of the other two fail, I don't lose my data, I'm able to replace the hard drive, and what we call a storage array, meaning that storage, those 2 hard drives that are working together, the one that failed and you replace it, the new one can be rebuilt using the parity drive. So it's a good way to make sure that you don't lose your data should hard drives fail. And by the way, they do fail. So you want to make sure that you are always accounting for that. Now that is the layer in which my data sits in constantly. So whenever I'm storing stuff for long term, that's where it ultimately ends up going. But when I interact with the server on a day-to-day basis, there's another layer that I interact with the most. And specifically when it comes to writing my data into the server, and that is what we call a cache layer, or for this particular server, and when we're looking at the software, it's called a cache pool. And a cache pool is nothing more than hard drives that work together in order to provide very fast writing speeds, or sometimes called as perceived speeds. And for this particular layer, I decided to use the fastest technology that we have available when it comes to storage, and that is NVMe drives. Now these NVMe drives, because they're the fastest storage technology that you can get today, again, they are a pool of drives that work together. So that way when I write to the server, I'm actually writing to the cache drive, and they provide the fastest write speeds possible. So that way, from my perspective, the perceived speed is so fast that I get the top performance. And then what starts to happen is once I write to those cache drives, every hour there's something that is called a mover. And all it does is takes the data from the cache drive and it moves it over into the spinning hard drives. And remember, the spinning hard drives is the slowest technology possible. And the reason why it's a slow process is because inside of those hard drives, there's actually mechanical things that are occurring. Specifically on those mechanical hard drives, there's actually spinning disks that are inside, and those are the disks that you're writing to. So of course, naturally, that would be a lot slower than actual NVMe's or SSD, which are no moving parts whatsoever. Now, not only do you have the mechanical aspect that makes it slower, but back to what I was saying about parity, in order to be able to reconstruct your hard drive array in case something catastrophic happens, that parity requires calculations. And those calculations happen in real time when you're actually writing to those drives. And so for that reason, that also contributes to writing to that drive very, very slowly, because you have the mechanical aspect, you have the parity aspect. Those things, if you were to write directly to those spinning hard drives, would seem like it's really, really slow. And again, if I am writing files that are very large in size, let's say 20 gigs, 30 gigs, right, that can take a long time. And so we really want the highest performance possible, so I'm not sitting there waiting for a task to be finished. So now you have a little understanding of the architecture of how the server works. Now let's talk a little bit about what the issue is that I've been experiencing. 3 years ago, when I was building the server, and I said to myself, what is the biggest file size that I would need to write to those cache pool drives at one time? I thought 1 terabyte was going to be more than enough. I said, I don't think that I would ever write more than 1 terabyte at a given time, because again, I can give the computer the time it needs in order to transfer from the cache drive to the long-term storage spinning hard drives, and I can just continually keep writing as long as it stays under 1 terabyte. Well, fast forward a little bit to today, and we're 3 years into this channel, and of course I have all this data and all of this video. Those file size have grown tremendously. Now currently, the way it sits, my C drive, which is the main hard drive, has about 1.8 terabytes worth of data on there, and then my D drive has about 1.5 terabytes worth of data on there between all the work that I've been doing. Now, as you guys can see, that is over 3 terabytes worth of data. Now, one of the things that I like to do, and especially once a month, is to back up my computer in case anything happens to it. And typically, every so often, I like to do a full backup, meaning you get rid of all the old backups and just do one full backup where it has all your stuff on there. And I do that to make sure that I manage how many backups I have, because you don't want to get carried away with that either. And when I was using my backup software in order to back up the computer, that is where I ran into the problem. How can you write to your cache pool when you only have 1 terabyte, but you're trying to write over 3 terabytes worth of data because I'm trying to back up the computer? And that is where the issue lies. During the backup process, I would get a message that the backup would fail. And then the other thing too that I didn't even mention when it comes to this particular server, I also have virtual machines that are running on it as well. And one of the virtual machines that I have on there is a virtual machine specifically for a cloud that I created for my family, so that way we don't have to pay Microsoft, Google, or you name your cloud provider. We created our own cloud in our house based off of the tools that we have available to us. Now, if you guys are interested in a video of how I was able to do that, let me know in the comments below. So not only did my backup fail and it would write to the hard drive and fill it up, but also as well, because the hard drive, especially the cache pool, was filled, that is also where I had a small amount of data for the virtual machine in order to run the cloud. Because my cache drives got full and my virtual machine was then paused, my files no longer started syncing, and I started getting notifications that my cloud was no longer working, which also prompted me to figure out a solution for this problem. So in order to overcome this problem now, what we're gonna do is we're gonna replace the 1 terabyte. So this is the original 1 terabyte that I put into that server. And there's 2 of them in there, like I said, in order to work as a cache pool. And we're gonna replace both of them with these guys, which is a crucial 4 terabyte NVMe. So a 1 terabyte NVMe to a 4 terabyte NVMe. So I'm gonna take you guys through the process of how I went and I upgraded them. Also, while I'm in there and I'm upgrading the machine, especially for those cache pool drives, on the long-term storage side, because the machine is open and because I've been rapidly filling it up, I figured it was a great time to also add another 16 terabyte for those mechanical spinning hard drives, because that's also another pool of hard drives working together. So let's start off with the cache pool. And first things first, we need to access the inside of our server. So as you can see here, we have 2 screws on the back side of that case. So let's go ahead and unscrew those, and we should be able to take out that case. So that way it exposes the motherboard, so that way we can see the actual NVMe drives. And as you can see on the motherboard itself, there are 2 NVMe drives. I'll go ahead and point them out for you guys, so that way you'll see where we focus on. And what we're going to do is we're going to remove and replace both of them. But first, it's going to be a 2-step process. And the first step is we're going to replace the NVMe drive on the bottom of the motherboard itself. So let's start the process. First things first is we have to remove the NVMe drive. The NVMe drive is held onto the motherboard itself with a Phillips head screw. So we're going to remove that screw that is holding down the NVMe drive on the motherboard itself. And here is the NVMe drive. And the NVMe drive is enclosed in a heatsink, because I will tell you guys, these drives get very hot, especially when you're writing to them and you're putting them under load. So the next step that we have in order to complete this is to remove the heatsink itself. So that way we can take the old heatsink and we could apply it towards the new NVMe drive. So let's go ahead and take care of that. Now, for your awareness, these NVMe drives, when they are inside the heatsink, they have this blue thin heat strip. It's almost like a double-sided tape, kind of. It helps adhere the NVMe drive to the actual heatsink itself for maximum heat transfer. So we want to make sure that we remove that from the old one and we put it on the new one. So that way when we go to install the new NVMe drive, we can have maximum heat transfer to that heatsink. With the new NVMe drive in hand, we can now apply that thermal double-sided tape that I was just talking about earlier onto that new NVMe drive. And once we apply that thermal double-sided tape, we can then put it back into the heatsink itself and we can enclose it. With the new 4 terabyte NVMe drive installed in the heatsink properly, we can now go ahead and put it back on the motherboard itself, and we can secure it to the motherboard using the screw that we took out before. Now let's take a pause here for a second, because I'm going to teach you guys a little trick here. And you might be saying to yourself, okay, great. Now let's go ahead and tackle the next NVMe drive in the motherboard itself. But we're actually not going to install the second NVMe drive just yet. The reason why we're going to do that is because we're going to actually power on the computer, go into the server OS. And in my particular case, I'm using a software called Unraid. So once we boot up our machine and we get into the Unraid operating system, which is the operating system that I use in order to run the server, you can see here that the cache drive, it shows there's an X on it because that was the drive that we replaced. And the reason why we didn't replace the second one is because we are going to utilize a feature that is called RAID 1 in order to rebuild our storage array. So what we're going to do here is we're going to apply the new 4 terabyte NVMe as a first cache, and then we're going to keep the original 1 terabyte cache drive on there, and we're going to hit start. Because you are in a RAID 1 configuration, and for those who are wondering what that means is that you are going to utilize one drive in order to rebuild the other. When it comes to RAID technology, RAID 1 gives you ultimate redundancy because you use 2 drives. One is going to be used in order to house your data. The second drive is going to be used in order to have an exact replica of the other drive. So if one drive fails, you can easily replace it and it will use the other one in order to rebuild itself. And remember earlier I said that I have some data on there, especially in order to run my virtual machines. So after hitting start, you're going to see that the software is going to go ahead and start rebuilding my cache pool drives, and it's going to bring over the data from the 1 terabyte over to the 4 terabyte. Once this is finished, our 4 terabyte NVMe drive will have an exact copy of all the data that was in my 1 terabyte NVMe drive. And then at that point, we can go ahead and shut down our server. And once we are done shutting down the server, we can go ahead and start the second process, which is let's go ahead and replace our cache 2 drive, which was the 1 terabyte, to the new 4 terabyte. So with the computer shut down again, we can now move on to installing our second NVMe drive. So same process as we did before. Now speaking of size, when it comes to RAID 1 technology, if you're going to mix a 4 terabyte and a 1 terabyte together, remember you lose one drive because it is specifically dedicated for backup of your data. So essentially you have to cut it in half. So in this case here, you have a 4 terabyte and a 1 terabyte for a total of 5. So essentially we're going to have 2.5 terabytes of total capacity. And after we're done upgrading to our 4 terabyte, remember we're going to go for a total of 8 terabytes. But because RAID 1 is specifically dedicating one of those drives in order to have redundancy or backup, you have to cut it in half. So we have a total of 8 after I install the 4 terabyte, and it's cut in half, which is going to give us 4. Now, since I have the computer open and I'm done installing the 2 NVMe drives, this also gave me the opportunity to add additional storage on the server, so that way, as I continue making videos for you guys, I don't run out of space. And I decided to go ahead and add an additional 16 terabytes of storage onto the server. And I'll walk you guys really quick through the process of how I did that. Now, this particular PC case has a special enclosure in order to house the hard drives. So what we're going to do at this point is we're going to install the hard drive in that enclosure. Once the hard drive is successfully installed in the enclosure, we can go ahead and flip around the PC case because we're going to need access to the other side in order to route the wires for the new hard drive. And on top of routing cabling, we also have to install the enclosure. As you see, we have some extra cabling here, especially for power and data, and that's exactly what we're going to use for this particular hard drive. So first things first, I'm going to unplug one of the hard drives in order to be able to work with that case. And the reason why I unplugged the hard drive is because there's a special feature that allows you to stack enclosures together. So now that the enclosures are stacked together, we can go ahead and reinstall them back into the PC case. Now that they're properly held inside of the PC case, especially we were using some thumb screws, we can go ahead and turn the PC case around, and we can finish installing the cabling in order to power up and also as well provide data for both hard drives. So with all the wiring complete, we can now go ahead and move that wiring and put it in such a way so that way when we put the panel back on, we don't actually damage those wires at all. So after both panels are installed, we can now go ahead and power up our server, and we can go back into the server operating system. And again, I'm using a software called Unraid. Now, same process as we did before when it comes to the cache pool devices. We're going to go in and we're going to replace our missing drive, and we're going to add the new 4 terabyte in there. And once we're done with that, we can go ahead and move up to our spinning hard drives. And our spinning hard drives is under the section that is called Array Devices. So as you can see, I have my parity, I have my disk 1, I have my disk 2. Now we can go ahead and add our disk 3, which was the new 16 terabyte hard drive that we just installed. So let's go ahead and add our 16 terabyte drive in there. We can go ahead and hit start. And now the software will actually work on two things at the same time. Number one, it'll go ahead and make sure that that 4 terabyte drive for our cache pool drives is automatically synced. So that way we'll have a total of 4 terabytes of storage for our cache. And the second thing it'll do, it will actually go ahead and check the new 16 terabyte, and it's going to check it for any disk errors. Then afterwards, it'll go ahead and clear the disk. And once it's done with that, it'll actually go ahead and format the disk and include the new file system. So it'll format the drive to XFS. And once it's done with that, it'll go ahead and add that new 16 terabyte into the array of disks. After some time, it actually finishes the work. And now you can see that I have 3 16 terabyte drives and 1 16 terabyte, a fourth one for parity. So now if I go back to my Windows box, you can see here that my drives still have the old storage amounts in there. So for example, I have 29.1 terabytes of storage available. But if we were to do a quick refresh, you can see that it was updated to a total of 43.6 terabytes of total available storage. All right, guys, and just like that, we've upgraded our machine, specifically the cache pool and also as well the long-term storage or the mechanical drive pool. I mean, you learned a lot about storage today, especially hard drives, the different types of technologies. Now, if you guys are interested in learning more about hard drive technologies or different concepts when it comes to that, let me know in the comments below, and we can do a video on hard drive technology or the different concepts, especially when you're gonna have to start learning about pools and different types of arrays. So that'll do it for this video, guys. Thanks for watching. More importantly, I hope that you learned something and you got to take a quick peek of my server, and more importantly, some of the technology that we use in order to make these videos come to life. So make sure you give me a like for the video as it helps the channel grow. Go ahead and subscribe to the channel and turn on your notifications so you're notified whenever I upload new videos to the channel. And share this video with a family member or friend, just in case they're interested in learning about server technologies. I'll see everybody in the next one.